inside the human body, the creation of life isn't really this peaceful miracle. I mean, it is actually a brutal microscopic war zone.
Oh, absolutely. It's an incredibly hostile environment in there.
Right, because we have this tendency to picture reproduction like, planting a seed in a quiet, perfectly curated garden.
Yeah, you just add some water and let it grow.
Exactly, just add water and nature does its tranquil thing. But when you strip away the poetry and look at the actual cellular biology, survival is anything but guaranteed.
Because the biological materials required to create a human life are just under constant aggressive bombardment.
Yeah.
Like from the very environment they're trying to survive in.
Well, welcome to the deep dive. Whether you are actively exploring reproductive health for yourself, or maybe you're trying to optimize your overall wellness, or you're just insanely curious about the hidden microscopic mechanisms that actually create human life, you are in the right place.
You really are.
Because today we are tearing into a dense but just fascinating set of medical notes that completely shattered my whole quiet garden illusion.
Yeah, the source material today is highly focused. I mean, it isolates one very specific variable in the reproductive equation, which is a compound called glutathione.
And our mission today is to unpack these notes, right? To demystify how human fertility is directly tied to this single internal compound.
Right.
We're going to look at how glutathione acts as basically the ultimate heavy-duty bodyguard for our reproductive system.
Yeah, we'll take you step by step through its specific effects on both female and male biology, and what happens when it fails.
And ultimately, the biological mechanics of how your body actually manufactures it.
What really stands out in these notes is that they move us away from those vague concepts of, like, wellness. And they ground fertility in a measurable cellular mechanism. I mean, we are looking at a very real biological battle that happens long before a pregnancy is ever even confirmed.
So let's get right into that battlefield. Before we talk about eggs and sperm, we really need to understand the overarching biological conflict happening in the body.
The big picture.
Right. The text identifies glutathione as one of the body's major internal antioxidants. And its primary job in reproduction is to protect eggs and sperm from what the notes call oxidative damage.
Yeah, and the rule laid out here is stark. When oxidative stress is high, fertility can decline.
Okay, so I think of oxidative stress kind of like a biological rust on a car engine.
Oh, that's a good way to put it.
Right, like if an engine runs hot, it generates exhaust. And over time, if the metal is exposed to the elements, it rusts, gears grind, and performance drops. But what is actually happening at a molecular level? Like, what is this biological rust?
Well, to push your analogy a bit further, think about what causes rust on a car. It's oxygen interacting with metal at an atomic level, sealing electrons and degrading the material.
Okay.
Inside your cells, a very similar process is happening. You know, every cell in your body is a tiny engine burning fuel, glucose, and oxygen to create energy.
Right, metabolism.
Exactly. But that metabolic process isn't perfectly clean. It produces cellular exhaust in the form of free radicals.
Free radicals.
Yeah. And these are highly unstable molecules, mostly because they are missing an electron.
And because they're unstable, they go looking for a replacement electron.
Right, desperately looking. A free radical will violently rip an electron from whatever is closest to it.
Wow.
Yeah. If the closest thing is a cell membrane, it damages the membrane.
Yeah.
If the closest thing is a strand of human DNA inside an egg or a sperm,
It rips an electron right out of the DNA structure.
it does, which causes fragmentation and permanent damage. That aggressive electron sealing process, that is oxidative stress.
So the reproductive cells are carrying the most precious, fragile cargo imaginable. I mean, the genetic blueprint for a human being.
Right.
And they are swimming through an environment filled with these unstable molecules that are literally trying to tear them apart.
It's terrifying when you think about it.
It really is. So where does glutathione come in? How does it actually guard against this?
Glutathione is essentially the ultimate bulletproof vest for your cells.
Yeah.
It's this highly concentrated antioxidant molecule that your body produces naturally. When one of those unstable free radicals comes barreling toward a reproductive cell's DNA, looking to steal an electron, glutathione intercepts it.
Wait, how?
It voluntarily donates one of its own electrons to the free radical.
Oh, so it takes the hit.
It takes the hit. It neutralizes the free radical before it can touch the cell's delicate machinery or the DNA.
That's amazing.
And the really remarkable thing about glutathione is that after it donates an electron, it doesn't just die. It undergoes this chemical recycling process so it can go back out and intercept another free radical.
So it's a reusable shield.
Exactly. It physically shields those delicate reproductive cells from their own metabolic exhaust.
Okay, so having established the mechanics of this bodyguard, let's look at how this protective shield operates specifically within the female reproductive system.
Let's do it.
The notes state that in women, glutathione shields developing eggs during a process called folliculogenesis. And because of this shielding effect, having adequate levels of glutathione is directly associated with better overall egg quality. Now, I want to flag that word, folliculogenesis.
It's a mouthful.
It is. It's basically the maturation phase of the egg inside the ovary.
Mm.
But why does the text single out this specific phase? Like, why is the biological shield so critical right then?
Because of the timeline and the energy demand. I mean, folliculogenesis isn't a quick process.
It takes a while.
Oh, yeah. An egg doesn't just appear ready for ovulation overnight. It takes months for a dormant follicle to wake up, grow, and mature an egg to the point where it can be released.
Months? Wow.
Right. And during that entire maturation period, the follicle is undergoing massive cellular changes, which requires a tremendous amount of energy.
Which means a tremendous amount of metabolic exhaust and free radicals.
Precisely. The fluid surrounding the maturing egg inside the follicle has to be absolutely saturated with glutathione.
Because the egg is so vulnerable.
Exactly. The egg is essentially a massive, highly complex cell that needs all its internal machinery, its mitochondria, its structural proteins, its chromosomes, to be in pristine condition.
Makes sense.
So if the body's overall oxidative stress is high, maybe due to age or environmental factors or lifestyle, and the local glutathione levels are depleted,
The egg is in trouble.
yeah, that developing egg is just taking hit after hit from free radicals for months.
So when reproductive endocrinologists talk about egg quality, they aren't talking about some, mystical property.
No, not at all.
They are largely talking about an egg that has successfully run this months-long gauntlet without its DNA or cellular machinery getting degraded by oxidative damage.
That is the direct, unbroken line the text draws. A high-quality egg is an undamaged egg.
Right.
Glutathione is the shield that ensures it makes it to the finish line intact.
Yeah.
Without it, the egg might still ovulate, but its internal structures are compromised, which cascades into huge problems later on.
Man, that sets up the female side of the equation perfectly. But human reproduction requires two halves.
It takes two.
So the conversation naturally has to shift to the male sperm. And the notes reveal something here that really challenges traditional biological assumptions.
Oh, big time.
The text states that in men, glutathione-related enzymes in sperm are linked to better early embryo cleavage. Now, I have to push back on my own prior understanding here.
Okay, what did you think?
Well, I always thought of the sperm as essentially just a microscopic delivery truck, like its only job is to swim fast, drop off a package of DNA into the egg, and then its job is done.
Right, the classic race to the egg.
Exactly. But this text suggests it's actively involved in embryo development after fertilization.
Yeah, the delivery truck model is a massive misconception that these notes correct. It forces us to entirely reevaluate the male contribution.
Okay, so what is it actually doing?
The sperm doesn't just drop off a package of chromosomes and clock out. It brings a really sophisticated molecular toolkit into the oocyte, into the egg.
A toolkit?
Yeah, and that toolkit includes specific glutathione-related enzymes.
Wait, how does it physically participate days later? I mean, I thought once the sperm head breaches the egg and fertilization happens, the sperm itself essentially dissolves.
Well, the physical structure of the sperm, like the tail, the outer membrane, that does break down.
Okay.
But the molecular payload inside the sperm head is released directly into the egg's cytoplasm. It's not just an instruction manual of DNA.
Right.
It's also the cellular scaffolding and the enzymes required to actually execute those instructions. And this brings us to early embryo cleavage.
Cleavage being the process where the newly fertilized single cell starts dividing, right?
Right.
One cell becomes two, two become four, four become eight.
Exactly. And that explosive cellular division requires an unfathomable amount of biological energy.
Which means more exhaust.
Right. As we established earlier, massive energy production means massive cellular exhaust. The newly formed embryo is instantly flooded with free radicals generated by its own rapid growth.
So if the embryo doesn't have a way to manage that sudden spike in oxidative stress, the division process just snalls out.
It stalls, or the cell divides abnormally, which leads to fragmentation. The text is telling us that the sperm's antioxidant capacity, the specific glutathione enzymes it carried in the egg, actively helps manage that explosive oxidative stress during those critical first few cell divisions.
Wow.
The oocyte has its own defenses, of course, but it relies on the sperm bringing its share of the protective tools.
So if the sperm was subjected to high oxidative stress during its own development,
Or if the male had low glutathione levels in general.
yeah, then that sperm arrives at the egg biochemically empty-handed.
Empty-handed, exactly.
That completely reframes the male factor. I mean, the sperm's health is literally dictating the structural integrity of the embryo days after they first meet, just because it failed to bring the necessary biochemical fire extinguishers to the construction site.
It's a very active participant in the developmental trajectory. And honestly, it also highlights why sperm are so vulnerable in the first place.
Why is that?
Sperm cells are incredibly tiny. They have stripped away almost all of their internal fluid, their cytoplasm, just to be light enough to swim.
That'd go fast.
Exactly. But because they have very little fluid, they have almost no space to store internal antioxidants like glutathione. Plus, their outer membranes are made of highly vulnerable polyunsaturated fats.
So they are essentially tiny torpedoes made of easily oxidizable fat, carrying sensitive DNA with almost no internal defenses, swimming through a biologically hostile environment.
That sums it up perfectly.
No wonder they need high systemic glutathione levels to survive the journey.
It is an absolute gauntlet. And if they sustain oxidative damage, even if they manage to swim and fertilize the egg, the DNA fragmentation they carry and the lack of enzymes they bring will completely compromise the embryo's ability to cleave and grow.
This connects perfectly to the next section of the notes. Because now that we understand how both the egg and sperm are protected individually and how that influences the earliest embryo stage, we need to look at how these micro-level mechanics translate to macro-level clinical success.
The real-world application.
Right. What actually happens in the real world of fertility treatments and pregnancy? The text points out that lower glutathione levels are associated with poorer fertilization outcomes after a procedure called ICSI.
Right, ICSI.
And for those who don't know, ICSI, intracytoplasmic sperm injection, is this highly specialized lab procedure where doctors bypass the whole swimming journey entirely. They physically take a single sperm and inject it directly into the egg.
It is the most advanced mechanical intervention we have for severe male factor infertility. They remove the need for the sperm to navigate the reproductive tract or even penetrate the egg's outer shell.
But the text says that even with ICSI, if glutathione levels are low, the fertilization outcome is still poorer.
Yes.
So doctors are doing the heavy lifting of physically combining the biological materials, yet it still fails. Why?
Because you can bypass the physical barriers, but you cannot bypass the chemical reality.
Oh, that's a good way to put it.
Science can put the two halves together in a petri dish, but science cannot wave a magic wand and undo profound oxidative damage to the DNA or the cellular structures.
Right, the rust is already there.
Exactly. If the sperm's DNA is highly fragmented from free radical damage, or if the egg's machinery is degraded because it lacked glutathione during folliculogenesis, forcing them together won't spontaneously create a viable embryo.
The biological materials themselves still have to execute the complex sequence of creating life.
They do. The spark still has to catch.
The notes go even further, though, moving beyond fertilization. They state that by reducing oxidative stress, glutathione improves implantation potential and can even reduce miscarriage risk when oxidative stress is the underlying factor. Why is reducing oxidative stress the common denominator dictating success at every single one of these clinical stages?
Well, if we synthesize all the mechanics we've discussed, reproduction is essentially the most complex, high-stakes construction project the human body ever undertakes. And at every single phase, creating the blueprints, laying the foundation, building the walls, there is a strict biological quality control check.
So implantation isn't just the embryo passively sticking to the uterus.
No. Implantation is a highly complex biochemical handshake between the embryo and the maternal immune system. It is an active dialogue.
Interesting.
Sustaining a pregnancy through the first trimester is an ongoing daily quality control check. If the materials are damaged by oxidative stress, if the embryo is struggling to divide properly, or if the cellular signaling is distorted by free radicals, the maternal body recognizes that the blueprint is fundamentally flawed.
So the body detects the microscopic damage and just halts the project.
It halts the construction. Clinically, that translates to a failed implantation cycle in an IVF setting, or a chemical pregnancy, or a miscarriage.
Wow.
The body naturally terminates pregnancies where the cellular damage is too expensive. So by maintaining adequate glutathione levels, you are neutralizing the free radicals before they can cause that damage.
Wow.
You are ensuring that the biological materials arrive at each of those quality control checkpoints in pristine condition, giving the body the clean, undamaged resources it needs to confidently continue the pregnancy.
Okay, so if glutathione is the ultimate rust-proofing, the critical factor at literally every stage, from egg maturation to sustaining a pregnancy, the immediate question any listener is asking right now is, how does the body get this, and can I make more of it?
Naturally.
And the final section of our text addresses exactly that. But before we get to the solution, let's talk about why you can't just take the obvious route. Like, why can't I just go online, buy a bottle of fully formed glutathione pills, and swallow them to build up my shields?
It comes down to the logistics of human digestion. You see, glutathione is a peptide. It's made of amino acids.
Okay.
When you swallow an intact glutathione molecule, your gastrointestinal tract treats it just like any other protein you eat. Your stomach acids and digestive enzymes recognize it, break it apart into its base components, and destroy its specific structure before it ever reaches your bloodstream or your cellular factories.
Oh, so taking oral glutathione is highly inefficient for raising cellular levels.
Very inefficient.
So instead of trying to ship the finished product, the text introduces glutathione precursors,
Right.
specifically a compound called NAC, or N-acetylcysteine. These are described as nutrients that help the body manufacture more of its own internal glutathione. It notes that NAC is widely used because it provides or donates cysteine, which directly promotes glutathione synthesis. Let's break down the mechanics of this internal factory.
To understand why NAC works, you need to know how the body builds glutathione. The factory inside your cells requires 3 specific raw materials, 3 amino acids: glutamate, glycine, and cysteine.
So it needs all 3 to assemble the final bodyguard molecule.
Yes. Now, glutamate and glycine are highly abundant. They are found in almost everything we eat, and our bodies have vast reserves of them. They are never the problem.
Okay.
But the third amino acid, cysteine, is relatively rare in the diet and is very easily depleted by the body, especially under periods of high stress, illness, or environmental toxicity.
So cysteine is the bottleneck.
It is the rate-limiting step in the entire manufacturing process. The cellular factory has plenty of glutamate and glycine, and it's just sitting there, assembly line paused, waiting for cysteine to arrive so it can finish building the glutathione molecule.
Oh, this makes the supply chain analogy perfect.
How so?
Well, if you want a factory to output more cars, you don't send them fully built cars. You find out what part they're missing. Like, if the factory has 1 million tires and 1 million engines but no microchips, the assembly line stops.
Right, yeah.
Taking a precursor like NAC is basically like backing a dump truck full of those rare microchips, the cysteine, right up to the cell's loading dock.
Exactly. The elegance of that biological system is what makes precursors so effective. You aren't forcing a foreign synthetic finished product into the bloodstream, hoping it survives digestion.
You are simply removing the supply chain bottleneck.
Yes. The factory your cells already knows exactly how to manufacture glutathione perfectly. The instructions are written right into your DNA. When NAC donates that cysteine, the assembly line immediately fires back up, glutathione synthesis ramps up naturally from within the cell itself, and the protective shields go up around the reproductive system.
It really shifts the perspective from just treating a symptom to actually equipping your own body to fight its internal battles more effectively.
It really does. Let's summarize the key takeaways we've extracted from these medical notes today. We began by defining the biological conflict, which is the constant threat of oxidative damage, where free radicals steal electrons and destroy the structural integrity of reproductive cells.
And we saw how in females, glutathione acts as this essential shield during the long, vulnerable months of folliculogenesis, protecting the developing egg's DNA from fragmentation.
Right. And we examine the male contribution, learning that sperm must bring vital glutathione-related enzymes into the oocyte to manage the explosive oxidative stress of early embryo cleavage.
Which was mind-blowing to me.
Yeah. We then connected those cellular mechanics to real-world outcomes, seeing how unmanaged oxidative stress triggers the body's quality control systems, leading to poor ICSI results, failed implantation, and even increased miscarriage risk.
And finally, we decoded the supply chain, learning that the body can be supported in manufacturing its own protective shields through precursors like NAC, which deliver the rare bottleneck amino acid cysteine directly to the cellular factories.
It's just a comprehensive look at how a single molecular mechanism really underpins the entire architecture of reproductive health.
It is. Now, the source text we use today also provides a very specific, actionable resource for those looking to apply this knowledge.
Mm.
If you want to explore your own nutrient levels, evaluate your oxidative stress, or see how precursors might fit into your personal fertility journey, the text states that the Berkeley Center for Reproductive Wellness offers a free fertility supplement evaluation. You can call them directly at 212-685-0985 to schedule yours. Again, that resource number from the notes is 212-685-0985.
Because understanding the science is the first step, but having a practical avenue to apply it to your own biology is the vital second step.
Absolutely. As we close out this deep dive, I want to leave you with a thought that builds on everything we've uncovered today. We started by discarding the illusion of the peaceful garden and embracing the reality of the microscopic war zone.
We did.
And we spent the last several minutes talking about free radicals, electron transfers, and the assembly line of cellular shields. But step back and look at the sheer scale of the implications.
It's massive.
If a tiny tweak in our internal supply chain, something as infinitesimally small as an NAC molecule donating a single unit of cysteine so a cell can manufacture one more antioxidant, if that microscopic, invisible event can fundamentally alter the trajectory of a developing embryo, dictating whether a new human life takes hold or fades away. How much of our overall health, our daily energy, our longevity, and our ultimate destiny is being silently dictated right now by microscopic cellular battles that we are completely unaware of?
It's wild to think about. We look in the mirror and see a single organism, but we are actually vast, sprawling universes of cellular conflict.
We really are. Thanks for joining us on this deep dive. Keep asking questions, keep looking past the surface of how things work, and we'll see you next time.